Hello and welcome to Geology, a channel dedicated to biology or the study of life. Ever wondered what makes it possible for you to jump, run, write, punch, or even dance? It all starts with the limb bones of the appendicular skeleton. Join us as we explore the key structures that make every movement possible and stay till the end to discover some mind blowing facts you never knew about your own bones. Start with the bones of the arms. Each arm has 30 bones, one humerus, one radius and one ulna, 8 carpals of the wrist, 5 metacarpals which make the palm, and 14 phalanges which are present in the fingers. The humerus is the bone in your upper arm that connects your shoulder to your elbow, providing support for the muscles and enabling arm movement. At the top, the head of the humerus fits into glenoid cavity of the scapula, forming the shoulder joint. In the middle of the shaft, there is a rough deltoid ridge where the deltoid muscles attach. At the bottom, the trochlea is a spool-shaped structure which connects with the ulna, allowing your elbow to flex and extend. The distal end of humerus also connects with the radius ulna at the elbow, making all these movements possible. Let's talk about the radius and ulna, the dynamic duo of your forearm. The radius is located on the lateral, that is the thumb side of your forearm, and is key in wrist and forearm movements. It's a bit shorter than the ulna but plays a major role in rotating your hand, especially when you turn your wrist. The proximal end of the radius connects with the humerus at the elbow, while the distal end links up with the carpal bones in your wrist, making your wrist flexible and mobile. You will also notice a bony prominence called the radial styloid process at the wrist end of the radius. Now, the ulna is on the medial or the pinky side of the forearm and provides the stability your forearm needs. It's longer than the radius and plays a major role in elbow movements. The proximal end of ulna features the olecranon process, which is a bony bump you can feel at the back of your elbow. And together, these bones give your arm its strength and range of motion, helping you to push, pull, and rotate with ease. The bones in your hands work together to give you the ability to do everything from typing to picking up objects. The carpals are the 8 wrist bones which form the wrist joint, allowing for flexibility and movement. These bones are like the foundation that supports all the different actions of your hand. Next, the metacarpals are 5 bones in the palm that connect the wrist to the fingers, forming the main framework of your hand. Finally, the phalanges are the 14 bones in your fingers, with 3 in each finger except the thumb, which has 2. These bones enable your fingers to move and grip objects, helping you to perform tasks with precision and strength. Let's now move on to the leg bones. Each leg has again 30 bones which work together to support movement and weight. These include the femur or the longest bone in the body, the patella or the kneecap which protects the knee joint, the tibia or the main weight bearing bone, the fibula which supports the leg but doesn't bear much weight, the tarsals which are the 7 ankle bones which help with foot movement, the 5 metatarsals in the foot which connect the ankle to the toes, and finally the 14 phalanges or the toe bones that allow for balance and movement. The femur is not just the longest bone in your body, it is also the strongest, providing essential support for all your movements. Its shaft is cylindrical and hollow, which makes it strong but light enough to handle the weight of your body. At the top, the head of the femur is spherical and it fits into the pelvis to form the hip joint, allowing for a full range of leg movements. The neck connects the head to the shaft, and this is the common spot where the fractures happen in older adults. Near the top, the greater trochanter is a large bony bump, and then there is a lesser trochanter which is smaller and which is found on the back. Both of these are key spots for muscle attachment. At the bottom, the condyles form the knee joint with the tibia, and then there is linea aspera, which is a rough ridge on the back of the femur, which gives muscles a place to attach, helping your leg move smoothly and powerfully. The patella or the kneecap might seem small, but it plays a big role in protecting your knee joint and giving your leg muscles more power when you extend your leg. Without it, jumping, running, or even walking would be a lot harder. The tibia, that is the bigger bone in your lower leg, is like the foundation of a building, holding up most of your body weight and connecting it to the femur at the knee and talus at the ankle. Meanwhile, the fibula, which may not carry much weight, but it acts like a sturdy sidekick, providing support and serving as an anchor for the muscles that help you move and balance. All these bones work together, allowing you to run, jump, kick without a second thought. The foot has several important bones, starting with the tarsals, which are the 7 bones that form the ankle and the heel. The largest of these is the calcaneus or the heel bone and the talus, which form the ankle joint. Moving forward, there are 5 metatarsals in the midfoot that connect the tarsals to the toes and helps to support the foot's arch. Finally, the phalanges or the toe bones are made up of 14 bones in total, with 3 in each toe except for the big toe, which has 2. These bones work together to provide the structure, stability, and mobility for walking and running. And that wraps up part 6 of 6 of our journey through the skeletal system. If you want the complete picture of how our bones work together, don't miss out on parts 1 to 5. They are packed with all the details you need to fully understand the bones that support and move your body. But don't go too far. Next time, we'll dive into the fascinating world of joints and how they help us to even move better. Stay tuned for that and keep learning with Givology.